Newton's first law, also known as the law of inertia, states that any object in motion stays in motion and any object at rest stays at rest unless acted on by a non-zero net force. Now let's see how this applies to this example. As you can see, the car will continue its motion when nothing is blocking it. Now this is what happens when this grasshopper is in the way. It slows it down.
Okay, according to Newton's first law, an object in motion, in this case the car, would continue in its state of motion unless an unbalanced force, like the grasshopper, is in its way, stopping it, so the car will continue in motion until something stops it.
Have you ever experienced inertia in a car while it is braking to a stop? In this example, with my dog Chester, there is no unbalanced force that is acting on him that changes his state of motion, which in this case is at rest. So Chester continues in a state of motion in the same speed and the same direction, which is why he jumps off of the seat.
Newton's second law states that acceleration produced by a net force on an object is directly proportional to the force applied on the object, and it goes in the same direction, but is inversely proportional to the mass of the object.
In this example, you can see me pushing the cart. For the empty cart, I need less force to make the cart accelerate. But when Sarah hops into the cart, I would need to apply more force in order to accelerate the cart because mass was added into the cart.
In this example, we can see how mass is inversely proportional to acceleration. So when we have a basketball, which has more mass than a volleyball, we need more force to kick the basketball than to kick the volleyball. Okay, so Newton's third law states that for every action, there's an equal and opposite reaction.
This is an example of Newton's third law because the action force is the air that is being released from the balloon and being forced out of the balloon, which causes a reaction force, which is the balloon being forced upward because of the pushing of the air coming out.
I would be like,
An action-reaction force, the force of the first object, would be the opposite from the force of the second object. So when we are playing golf, the rightward force of the golf club would be a leftward force when it hits the ground, and then the ball would have like a rightward force applied on it.